Hey everyone, today we're going to be talking about solving trig equations again. So we talked last class and we focused just on the interval from 0, inclusive interval of 0 to 2 pi. So we're going to go past that and talk about solving for all the angles and how we represent all of our solutions past that interval. And then we are also going to solve on that interval for trig equations that have multiple angles. So here are our steps to find all of our solutions. So to find all of our solutions, we're going to start by finding the solutions in the unit circle, and then we're going to use coterminal angles. So sine and cosine, remember, repeat every 2 pi. So we're going to add 2 pi in. N represents how many times, or what's your number, how many times you're going around the unit circle, whatever it might be, and we'll talk more in detail about that. And tangent, of course, repeats every pi, so we're going to add pi in. So we're going to solve this problem just like we did last block. So we're going to add 1 to both sides, giving us 2 cosine of x equals 1. We're going to divide both sides by 2. And that's going to say that cosine of x equals 1/2. Okay, so last block we just did it on that normal one around the unit circle, and we said, okay, well, that's cosine of x equals 1/2 means x equals either pi over 3 or x equals 5 pi over 3. Right? Today we're going to show how to represent that infinitely, I guess you could say, we're going to add 2 pi n, say plus 2 pi n, and those are my solutions. Now, for this one, I'll take it a little bit further. Okay, what does that mean? Well, let's say n is 1. Okay, so after pi over 3, let's see what we have. So we would do pi over 3 plus 2 pi. 2 pi is the same as 6 pi over 3. So when we add those together, we get 7 pi over 3. So again, those are coterminal, so it makes sense that they'll have that same value. And then if my n was 2, all right, we'd be adding 4 pi. And 4 pi is the same as 12 pi over 3. So when we add, we get 13 pi over 3. And we could keep going. We could do the same, with this 5 pi over 3. We're adding 2 pi the first time. So that's going to get me 11 pi over 3. We can add, 4 pi, and that will get us 17 pi over 3. Okay, so we can go on infinitely, and that's why we represent them by what's in purple there. So here's our next one. We're going to add 1 to both sides. Get 3 tangent squared x equals 1. Divide both sides by 3. It's going to get me tangent squared x equals 1/3, and then we're going to square root both sides. Remember, whenever you take the square root, you always get 2 solutions. So you want to put plus or minus. When you square root a fraction, you square root the numerator and the denominator. And so notice we have the square root of 3 in the denominator. Now we could rationalize that, or we could just know, well, if it's got a square root of 3, it's either got to be the pi over 6 family or the pi over 3 family. And then you can just play around with your coordinates. So we know the coordinates of pi over 3 and we know the coordinates of pi over 6. Tangent, you do your y divided by your x, and you'll notice if you do 1/2 divided by root 3 over 2, you will get 1 over root 3. So this is definitely the pi over 6 family. So that means x could equal pi over 6. Remember, this is plus or minus, so we're going to do everything. So the positives are, pi over 6, sorry, brain fart, 7 pi over 6. The negatives would be 5 pi over 6 and 11 pi over 6. So to represent all of our solutions, because these are both our positive answers, we can actually just represent it as pi over 6 plus pi n. And to represent the 5 pi over 6, we would say 5 pi over 6 plus pi n. All right, we're going to divide by 4. Got cosine squared x equals 3/4. We're going to square root both sides. and we get cosine of x equals plus or minus the square root of 3 over 2, which again happens to be the pi over 6 family. So when is it positive root 3 over 2? That's pi over 6 and 11 pi over 6. When is it negative root 3 over 2? That's 5 pi over 6 and 7 pi over 6. So once again, to represent this time, we're going to say x equals pi over 6 plus pi n, and x equals 5 pi over 6 plus pi n. So now let's talk about what we do when we have, something other than just x or theta inside our parentheses. So we're going to start off, with all of these problems. All right, what we're going to do, we're going to solve just like we did before. Okay, we'll express all of the angles just like we did before, and then we're going to list all those angles until we get to anything that is greater than or equal to 2 pi. So now we're back on that interval from 0 to 2 pi for these. So let's isolate first. We're going to add 1. Divide by 2. That gets us cosine of 2 theta equals 1/2. Now, so right now we're just going to pretend like it's a normal theta. You could call it x, y, whatever, and say, okay, for what angles is that true for? And we're going to set that up. So we should know that that happens with pi over 3. I'm going to put plus 2 pi n to represent everything. And it also happens at 5 pi over 3. Okay. The 2 pi n's are just what we add to represent everything. All right. So now we're going to divide both sides by 2 because we want to isolate theta. Now, when you divide pi over 3 by 2, it's like multiplying by 1/2. So you're going to get pi over 6. And then 2 pi n divided by 2 is just pi n. All right. Do the same thing over here. Divide by 2. You get theta equals 5 pi over 6 plus pi n. Okay. So now we're going to actually list out, everything. Okay. So we're just going to say theta could equal pi over 6. That's obvious because that's our first one. Okay, if n was 0. Okay, now what if we add just 1 pi to it? Remember, pi is the same as 6 pi over 6. So that's going to get me 7 pi over 6. If I do that again, well, 7 pi over 6 plus another 6 pi over 6 would get me 13 pi over 6. That's more than 2 pi, so I don't have to go any further there. Over here, we're going to do the same thing. But this time we got 5 pi over 6. Remember, we're adding 6 pi over 6, and that's going to get me 11 pi over 6. If I try it again, I'm going to be over 2 pi, so those are my 4 solutions. Okay, my next one, it's already been isolated. Remember that, you can think about, okay, well, I'm just going to think about what this could be if it was just x, not 3x. And whenever you see a square root, we know we're thinking about either pi over 6 or the pi over 3 family. And for this one, it's going to be the pi over 3 family because the square root of 3 over 2 divided by 1/2 does get you the square root of 3. So tangent's positive square root of 3 at pi over 3 and at 4 pi over 3 because we're thinking about the third quadrant. And then I'm going to add pi n because it's tangent. So 1 period is just pi. So we're going to divide both sides by 3. When I divide pi over 3 by 3, that gets me pi over 9. And then I have pi over 3n here. When I divide 4 pi over 3 by 3, I get 4 pi over 9 plus pi over 3n. Okay, so now we're going to list out all of our solutions here. So we start with pi over 9. Now, pi over 3 is the same as 3 pi over 9. So when we add, we're going to get 4 pi over 9. If we add again, that'll give us 7 pi over 9. If we add again, that'll give us 10 pi over 9. If we add again, that's going to get us 13 pi over 9. If we add again, that'll get us 16 pi over 9. And then 19 pi over 9 would be over 2 pi. Now if you look at your other one, you'll notice that, oh hey, 4 pi over 9 was what I wrote second right here from just adding. So we actually got our other solutions for that. So those are our 6 solutions there. All right, last one. So we're going to isolate, divide by 2. That's going to get me cosecant of x over 3 equals 2. Now remember, cosecant is the same as 1 over sine, so I can set this as sine of x over 3 equals 1/2. All right, so when is our sine 1/2? That's the pi over 6 family. So I'm going to set x over 3 equal to pi over 6 plus 2 pi n. And I'm going to set x over 3 equal to 5 pi over 6 plus 2 pi n. All right, so now we're going to multiply both sides by 3. We're going to multiply both sides by 3 because that's how you get rid of division. Okay, and when we do that, we get x equals, now 3 times pi over 6 is going to get me pi over 2, and then that's going to be plus 6 pi n. All right, over here, we're going to have x equals 15 pi over 6. Let's see, 15 pi over 6. Those are both divisible by 3. Get me 5 pi over 2. Okay, plus 6 pi n. Now, the thing is, all right, 5 pi over 2 is already over, what we need, which is 2 pi. So we're not going to get any more solutions from this. All right, and then 6 pi is the same as 12 pi over 2. If you add 12 pi over 2 to 1 pi over 2, that's going to get you 13 pi over 2, which is well over 2 pi. So our only solution for this one is just x equals pi over 2. And that's how you solve with multiple angles.